Homework 2 is about manipulating algebraic expressions. What we're going to do here is we're going to do multiplication, addition, division, subtraction, and even some functions involving exponents to algebraic expressions. An algebraic expression is defined as an expression with a variable, with an x, with a y, with both, with other letters, anything besides for just plain old regular constants, which are considered numbers. So let's take a look at number 1. Now, number 1, you've got a multiplication function and you have a subtraction function. Now, remember, you can only do a subtraction function or an addition function if the two terms have the exact same variable. So there may not actually be able to be any combining over here. However, let's start over here. So we can start with this multiplied by this, a monomial by a monomial. And when that happens, you see what you can multiply together. The 8 and the 3 can be multiplied together. That, of course, gives you 24. The x can't be multiplied by anything because there's an x here and no x here, so the x just stays the way it is. The y, on the other hand, can be multiplied. When you multiply two two letters of the same variable, in other words, two y's, you add the exponents. Since this y is really the same thing as y to the first power, and this is y to the fourth power, y to the first power times y to the fourth power, which is like y times y, gets you y to the fifth power. You add the exponents, so what you have over here is 24 times x times y to the fifth power. Over here, you've got 3 times 7x, so the 3 times 7 is 21, and the x stays by itself. And there's nothing you can do beyond this because the two terms do not have the same variable. So this is your answer. The second one here, you've got a situation where you've got multiple terms in each set of parentheses. It's the 2x minus 5 being multiplied by the entire x squared minus 3x plus 1, which means each of these terms, the 2x and the negative 5, has to be multiplied by each of these terms. And then in the end, we'll see what we can do in terms of combining the variables. So first, let's try 2x times x squared. Well, the 2 stays by itself because there's nothing to multiply it by. X times x squared is x to the third because this is really the same thing as x to the first. And you add the exponents, so this becomes x to the third. 2x times negative 3x becomes 2 times negative 3, which is negative 6. X times x, which is x to the second, because we added the exponents, the 1 and the 1. And then finally, 2x times positive 1 is simply positive 2x, because anything times 1 is itself. Now let's try the negative 5, which is the second term. Negative 5 times x squared is negative 5x squared. And I'm going to put it over here. And the reason why I'm going to put it over here is because these two have the same variable. If they have the same variable, you're going to be able to combine them. That's why I'm going to put things that have the exact same variable on the same line. Then we've got negative 5 times negative 3x, which is negative times a negative, so it's a positive. 5 times 3 is 15x. And then finally, the last one, negative 5 times positive 1 is negative 5. So here, we can kind of add these terms together. We can combine these terms to the extent that they have the same variable. The 2x cubed is going to stay because it doesn't have the same variable at all. These two terms can be combined. Negative 6 minus 5, just add, or in this case, subtract the coefficients. Negative 6 minus 5 is negative 11. And when you do that, of course, the variable stays the same. Just like if you had 6x plus 5x would be 11x, so negative 6x squared minus 5x squared would be negative 11x squared. Here also you have the same variable. 2 plus 15 is 17x. And the negative 5 stays by itself, and that is... There's nothing more you can do to combine these because all of these have different variables, all of the terms in there. When you have a situation like this, where there's no multiplication going on, in other words, you don't have this whole term being multiplied by that whole term, instead you have this whole term being subtracted. So here we're going to try to line things up with the same variable. Let's say, for example, this is a negative negative, so this term gets added to this term, because again, a minus and minus, a double negative is a negative. And this is going to be on the same line as this because they're the same variables. So we can say positive 2x squared y to the third. The middle is a negative negative again, so it's a positive. And again, the variable is xy, so we'll put it under this term, which also has the variable xy. So we'll say plus 3xy. And the last one, which is negative positive, which is a negative, we'll put it over here because it has the same variable as the y squared. So if we combine these, this is the same variable as this, so we can add the 3 and the 2, and we've got 5x squared y to the third. The middle, we've got negative 1xy. Remember, when there's no coefficient, it's assumed to be 1. So negative 1 plus 3 is positive 2, and the variable stays the same, which is xy. And then you've got 4 minus 5, which is negative 1, or just plain negative y squared. And because of the fact that you have no more terms that have the same variable as each other, this is the final answer that you have to leave it with. Number 4, for homework number 2, is a division problem, which is worked in really the same way. Just like when you multiply two letters, two variables, you add the exponents. When you divide them, you subtract the exponents. So over here, we've got constants, we've got numbers that are being divided by each other. Well, first of all, the entire thing is going to be a positive divided by a negative. So the entire answer is going to be a negative. You know that right away. 24 divided by 2 is 12, so we can put a 12 here. X to the second minus divided by, x to the fifth is x to the second minus 5, which is x to the negative 3. So we can leave that as x to the negative 3. Then y to the 13th divided by y to the second, well, you have to subtract negative 2. So it's 13 minus negative 2, which is y to the 15th. Now, if you wanted, remember, something to a negative exponent is the same thing as 1 over that amount. So you can also write it, which is probably the best way to write it, would be 12y to the 15th, and then put x to the third on the bottom. Essentially, we just kind of flipped it. Instead of making it x to the negative third on top, we made it x to the third on the bottom, which is the same thing. This example over here, well, here we have a situation where one term is being added to another term, but there's only one variable that's the same as each other. Essentially, we've got, if you put this term on top, the one on the left on top, remember, this is not being multiplied, so you don't have to distribute, you don't have to multiply them out, this is just being added. So you add the 10x squared, but there is no 10x squared on the other term, so we're just going to put it over here by itself. The 7x you can put over here because you can combine it with this term. You always look to see if they have the same variable, and of course there's nothing similar to the 1. So we can put the 10x squared over here. It's 0 plus 10x squared. 5x plus 7x is 12x, and then we've got minus 1, and there's nothing really you can do over here to simplify it any further because there are no two more terms with the same variable. The next few problems are similar to the ones that we just discussed. They're all really doing the same thing. In number 6, you're also going to want to write out the first term. So let's say 6x plus 2y plus 9. Now, this is being added to the second term, so we want to try to combine all the terms that we can combine. Now, because this is a plus sign, that means all these signs stay the same. This is a negative, this is a negative, this is a negative. So the 3x lines up with the 6x, and we'll call it negative 3x. The 5y lines up with the 2y, and of course negative 2y, and then the negative 8. So now we can combine them. 6x minus 3x, 3x. 2y minus 5y, well, 2 minus 5 is negative 3, so we'll call it negative 3y. And of course, 9 minus 8 is positive 1. And since they're all different terms, this is the best answer that you can come up with. Number 7, we are going to multiply out, because here you do have a monomial multiplied by a binomial, and then another monomial multiplied by another binomial. So we're going to use the distributive property. This times this, and then this times this, and then we'll do the same thing on the other side. X times x, x to the second power. Remember, it's not 2x. X plus x is 2x, because when you add them, you add the coefficients. But when you multiply them, you add the exponents. So This is x to the first, this is x to the first, so that's x to the second, plus x times 1, which is 1x, or x. Now on this side, we can do the multiplication out also. Negative x times x, which is negative x squared, that's this times this, and then this, which is negative x times negative 1, which is positive x. Now, can we combine them? Well, yeah, we can combine this with this, x squared minus x squared, which is 0, which is, 1x squared minus 1x squared is 0x squared, and 0 times anything is 0. And then you've got x plus x, which is 2x. So the final answer is just plain 2x. Number 8 is a combination also, where it's a monomial. That's the 2x squared times a polynomial, really a trinomial over here. So you would distribute this in all three directions. 2x squared times 3x squared, well, you can multiply the base, 2 times 3, which is 6. X squared times x squared is x to the 4th power, again, because when you're talking about the x's, you add the exponents. The second term, 2 times 5, 10, and x squared times x, x to the 3rd power, right? This has an exponent of 2, this has an exponent of 1, so altogether it becomes x to the 3rd. Then you've got 2x squared minus 4x, which is negative 4 times 2, which is 8, and the x squared just stays because there's nothing to multiply it by. And this is now the best answer. Nothing more you can do to simplify this, and that's your final answer. Number 9 is something that's a little bit more complex, but we have to realize this is y plus 7, and the whole thing is to the 3rd power. So that's really the same thing as saying y plus 7 times y plus 7 times y plus 7, and then of course you still have the plus 4 left over at the end. Well, when you do that, you got to do them separately because it's this times this, and then the product times this. So let's do y plus 7 times y plus 7 first. Now, if you recall, you do FOIL here. First, outer, inner, last. First is y times y, which is y squared. Then outer is y times positive 7, which is positive 7 times y, or positive 7y. Then inner is 7 times y, which is another plus 7y. And then last is plus 7 times plus 7, which is plus 49. And now you've got this whole answer times y plus 7. See, now now of course we could leave the plus 4, which we're not going to have to worry about right now. But this is what makes it a little complicated, because now you've got 4 terms times 2 terms. So each of the 4 terms has to be multiplied by each of the 2 terms. So let's do the y times everything. And maybe we'll make them on separate lines to try to combine them later on. So y times y to the 2nd, that's simple enough. That's y to the 3rd, right? Because you add the exponents. Now you've got y times positive 7y. So you got positive 7y to the 2nd, again, because the 7 doesn't combine with anything, but the y times y is y to the 2nd. Then you've got y times positive 7 again. And then you've got, actually the truth is, well, we can do it this way. We could have combined it earlier, but it really doesn't matter. We could do it this way as well. Either way will work. Plus 7y squared. And then we've got y times 49, which is positive 49y. Okay. Now, of course, at this, well, okay, let's leave it the way it is, and we'll combine the 7y. At this point, we could combine the two 7y's to make this into positive 14y, but, it doesn't really matter one way or the other. We could do it later, we could do it now, either way. Okay, 7 times y squared. Again, now we're doing the 7 times everything. So 7 times y squared is positive 7y squared. Then you've got 7 times 7y, which is positive 49y. Then you've got 7 times 7y again, which is another positive 49y. And then you've got 7 times 49, which is 343, I believe. And then you've got, of course, the plus 4 eventually, which we saved later on. So let's combine everything that could be combined. And let me make a little more room here. So we still have the y cubed, which isn't going to combine with anything. We've got 3 of these 7y squareds, and they're being added to each other. So it's 7 plus 7 plus 7, which is 21y. Then we've got 49 plus 49 plus 49, y, all y, which is 147y. And then we've got 343 plus 4, we've got plus 347, and that's our answer, because we've combined everything that we needed to combine. So actually, if we would have combined this and made this into 14y, it would have been a little simpler, because instead of multiplying each of these by 4 things, we would have only had to multiply them by 3 things. But either way, that works. Let's do a problem that's a little simpler. 2m times 2m, which is 4m squared. 2 times 2 is 4, and times m is m to the second. Then we've got the FOIL, so the outer, negative 6 times positive 2m, so that's negative 12m. Then we've got the inner, positive 6 times 2m, which is positive 12m. And then the last, negative 6 times positive 6 is negative 36. Now, the middle two, as you might notice, are going to cancel out. Positive 12m minus 12m, or negative 12m positive plus 2m plus 12m is 0. So your answer is going to be 4m squared minus 36. This, by the way, is known as the difference of two squares. Whenever you have two of the same terms, and the only difference is that there's a plus sign in one of them and a minus sign in the other, by definition, the outer and inner terms are going to cancel out, leaving only the outer times the outer, the last times the last, and the first times the first are going to be the only two terms. For example, if you have x, let's say, plus 3 times x minus 3, your answer is going to be x squared minus 9, because the middle two terms are going to cancel. X times x is x squared, outer is negative 3x, inner is positive 3x, and then the last is negative 9. These two are going to cancel out, leaving only the x squared minus 9.